For the second part in section 8.1, we are going to look at some word problems, some story problems, and the problems that are here in our notes always give us a picture. These 4 problems will give us a picture of what the problem is describing. Sometimes the problem will not provide a picture, and it is up to you to draw that picture of what they're describing. All right, so you need to draw those right triangles and label the sides with the information that they give you. In this first problem, it says that a surveyor can measure the width of a river by setting up a transit at a point C. So they're setting up this transit here on one side of the river and taking a sighting of point A on the other side. So here's the sighting, point A on the other side. After turning through an angle of 90 degrees, so here's our right angle, the surveyor walks a distance of 200 meters to this point right here. Using the transit at point B, the angle is measured and found to be 20 degrees. So this angle right here is 20 degrees. What is the width of the river rounded to the nearest meter? So really what we have here is just a right triangle. I know this angle is 20. B is the width of the river. So I'm finding the length of side B. I know that this is 200 meters. So in relation to this angle, I want to find the side opposite, and I know the side adjacent. So opposite and adjacent to this angle is tangent. So the tangent of this angle, which is 20 degrees, is the side opposite, which is B over 200. And now to solve for B, I'm going to bring my calculator in here, and I've already checked to make sure that I'm working in degree mode. Always double check your calculator at the beginning of working through some problems just to make sure you're in the right mode. And to find B, I'm going to take 200 and multiply it by tangent of 20. And I just need to type that on my calculator exactly as I see. So 200 times tangent 20, and I get 72.79. It does say to round to the nearest meter, so that would be 73 meters. And that is the width of the river. Example 5. A straight trail leads from the Alpine Hotel with an elevation of 8,000 feet. So this is starting at 8,000 feet. This is like above sea level, to a scenic overlook elevation of 11,100 feet. So from here to up here, this is 11,100. This distance from horizontal from 8,000 to 11,100 is 3,100 feet. So I'm going to draw another picture. These pictures don't copy very well. So the height of this triangle is 3,100, and it says the length of the trail is 14,100 feet. So going from the hotel, walking up this trail is 14,100. They want to know the inclination or the grade of the trail, and that would be the measure of this angle opening. All right, so this is the angle that we want to find. And to find this angle, we're going to use the lengths of two sides. So we know the side opposite and the hypotenuse. So opposite over hypotenuse is sine. So I know that sine of my angle is going to be 3,100 over 14,100. Now, to find the measure of the angle, we need to do inverse sine. All right, so on both sides here, I'm going to do sine inverse. So the sine inverse and the sine are going to cancel, and that means that the measure of my angle is going to be the inverse sine. So I'm going to do inverse sine, and then I can just type in that ratio, 3,100 divided by 14100, and close the parentheses, and this will tell us the measure of the angle, which is about 12.7 degrees. Okay, so 12.7 degrees. Okay, so if they don't tell you how to round, like in example 4, it does tell you round to the nearest meter. This one doesn't tell us how to round, so round to what you think is reasonable. All right, so 12.7 is reasonable, 12 degrees, 13 degrees. If I round up, this would be 13 degrees. Okay, so we're going to make our best judgment in that case. In example 6, here it says that meteorologists find the height of a cloud using an instrument called a ceilometer. And a ceilometer consists of a light projector that directs a vertical light beam up to the cloud base and a light detection that scans the cloud to detect the light beam. On December 1st in 2014 at Midway Airport in Chicago, a ceilometer was employed to find the height of the cloud cover. It was set up with its light detector 300 feet from the light projector. All right, so here's the instrument right here, and the light projector is 300 feet from that instrument. So we have a triangle here that has a base of 300 feet. It said is if the angle of elevation from the light detector to the base of the clouds is 75 degrees. Now, angle of elevation just means how much does this angle open? Okay, so this angle opens 75 degrees. What is the height of the cloud cover? So I'm finding the height on this side of the triangle using 75 degrees as my angle. I want to find the side opposite. I know the side adjacent. So opposite and adjacent are tangent. So I'm going to do tangent of my angle, which is 75 degrees, equals opposite h over adjacent, which is 300. So h is 300 tangent 75 degrees. So 300 times tangent 75 gives me 1,119.6. Now, if I'm measuring cloud cover, that 0.6 is really insignificant. So I would round this to the nearest foot. So I would have 1,120 feet. So the height of the cloud is 1,120, and this is measured in feet because that's the measure that I have for the base of the triangle. Example 7 says adorning the top of the Board of Trade building in Chicago is a statue of Ceres, the Roman goddess of wheat. From street level two observations are taken 400 feet from the center of the building. All right, so here's the center of the building. 400 feet is a distance right here. And what you can do is you can use an instrument, some kind of ometer. I have to figure that out. I don't remember. But there's an instrument that can open up and you can measure angles based on where you are and a specific point. So this person measured the angle to the base of the top of the tower, and then again to the top of the statue. And it's really thin in here, but if we pull that apart, this is showing 400 feet from the base of the tower, and an angle goes up 55 degrees to get to the base of the top of the building. All right, so we want to find out how high is the top of the building. And then the second triangle, we're in the same position, and now this point here is the top of the statue. All right, so this angle is a little bit bigger. 56.5 degrees is my angle that measures from the base of the ground to the top of the statue. So if we find the top of the building, and then there's this statue up here, and the top of the statue would be over here, we can just subtract these values. Let's make this an H. All right, so looking at this angle, 55.1, the side opposite and the side adjacent is tangent. So tangent of 55.1 is opposite B over adjacent 400. So B is 400 tangent 55. So 400 tangent 55 is 571.3. So let's say B is 571.3. Now, to the height of the top of the statue, I'm going to use this angle, 56.5, and the height is opposite and adjacent is 400, so I still have tangent of 56.5 equals the height over adjacent is 400. So here, height is 400 tangent 56.5. So this would be 604.3. So here I'm rounding off to 0.3 because I'm looking at a statue that is the difference of these two values. So rounding off to either the nearest foot or the nearest tenth of a foot is probably the best unit. I don't need hundredths, thousandths, or any other further places after the decimal. So now if we take this height of the statue, which is 604.3, and subtract that from the base of the top of the building, which is 571.3, this is going to give us 30.9. Okay, and our units are measured in feet. And I could even say that that's 31, but I'm going to leave it as 30.9 feet. All right, so just remember, if you are encountering a story problem and there is not a picture there, I will be looking for the pictures that describe what the problem is telling you. All right, so you have to make sure you draw the pictures.